Okay, hi, Assalamualaikum. My name is Ahmad Tanjung bin Muhammad. Okay, this is my bachelor degree project title, which is comparison of impact duration between experiment and theory from CHAPI impact test. And this is my supervisor, Dr. Muhammad Basri bin Ali. Okay, for the introduction, the CHAPI impact test was created in 1900 by George Augustine Albert Chappie. Okay, this is widely used to assess the relative hardness of a material. Okay, this test is to determine the absorbed energy under impact stress and a low cost quality control method. Okay, for the standard specimen of Chappie impact, they are using 55 millimeters times 10 millimeters times 10 millimeters with notch at the center of the specimen. Okay, for the objective for this project is to study the impact signal duration using Chappie impact. Next, to analyze the comparison between different material and specimen thickness. And lastly, to compare the impact duration between experiment and theory. Okay, for the scope project, one is to capture the strength signal test during impact Chappie test. The next one, test the different material between aluminium 6061 T6 and steel 304 with different thickness using standard ASTM E23. Next, to conduct the experiment Chappie impact machine using velocity 5.4 meter per second. Okay, the last one is to compare the impact duration result from experiment and theory. Okay, next for the literature review. As you can see, the Chappie impact test conducted by Kruger at State University of Sao Paulo in 2003. Okay, using the speed 5.5 meter per second using AISI 4140 steel with the capacity of 300 joule. Okay, as you can see picture on the right, using Chappie impact connected to the computer to get the result. Okay, picture on the left, as you can see the result, force times time meter per second graph. Okay, as you can see the impact time is below 0.5 meter per second, so the impact duration is very little. So the force is used mostly around 20 or more kilonewton. For the literature review, okay, this is a conducted experiment by Robert in 2001 in Loughborough University. Okay, he's developed a golf ball impact duration measurement technique. Okay, as you can see picture on the left, you can see the first one is using copper strip method, and at the middle he's using aluminium foil method, and the last one he's using silver pen method. Okay, picture on the right side. As you can see on the graph, copper strip method is little more less than the aluminium foil method during the impact duration. Okay, so the silver pen method is less than both aluminium and copper strip method. Okay, this is the graph on the bottom. As you can see, the impact duration begin to drop at 0.35. Okay, next, this is the equation based on MB Ali on 2013. Okay, this is the equation to get the impact duration. Okay, as you can see, the T0 equals to 2.94 times 5 over 4 m, which is for the mass, times n power of 1 times v for the velocity, 1 over 2. Okay, times power 2 over 5. Okay, as you can see for the m is the total mass equals to 1 over m1. M1 refer to the mass of the impactor, and after that plus 1 over m2 which is the mass of the specimen. Okay, V for the velocity during impact, we are using 5.4 meter per second. Okay, n power of 1 which is equals to 4 square root r1 which is radius spherical impactor over 3 pi times k1 plus k2. Okay, k1 equals to 1 minus v1 power of 2 equals to pi e1. E refer to the Young modulus striker and specimen respectively. Say, okay, so the information for the Poisson ratio Young modulus, we have we have the data. Just put in the n1 equation, and then we put it back on the impact duration time or at the top. Okay, okay. For the methodology, okay, in this topic, contain the beginning of Chappie impact test until it's finished. Okay, next the process involved in the experiment. Okay, after that the process of strain gauge installation, and lastly specification on specimen. Okay, the first one, the flowchart experiment process from the beginning until the end of experiment. Okay, first we start, and then we select the material selection. We using aluminium 6061 T6 for the steel 304. Okay, then we strain gauge installation. After that, we collect the impact strength signal on the based on the graph. After that, we analysis the impact duration based on the graph on the computer. Okay, and then we impact duration comparison. This impact duration comparison, we have to compare the result between analysis theory and the experiment. Okay, for this is the equipment connection during Chappie impact test. Okay, as you can see the first picture, that is the Chappie impact machine. Okay, on the right side, that are the strain gauge. Okay, on the bottom you can see the system detect and also the computer. Okay, the connection between these four pictures. Okay, you can see the strain gauge is connected to the pendulum cycle. As you can see the picture that have rod, the black rod. Okay, we put it strain gauge on the striker. Okay, and then the strain gauge we connected to the system EDAC. As you can see that. Okay, the system EDAC, and then we connected to the computer. So when the striker swing onto the specimen, you can send the information through the system EDAC, and then the computer will appear the result based on the experiment. Okay, next for the flowchart strain gauge installation procedure at the striker. Okay, then we start. After that, we surface treatment. We are cleaning the surface strain gauge using small knife, and also we strain gauge installation at the striker, and we are using adhesive keyring. After that, we are using lead wire connection to the system heater, and then using coating. So the strain gauge don't have the empty space or bubbles on the striker. And then we're doing the final checking, and then the end. Okay, next for the specification based on the ASTM E23. Okay, so the specific specimen, as you can see, the length of the specimen is 55 millimeters. So for the height is 10 millimeters, and for the width is 10 millimeters. Okay, as you can see, the notch, it has 45-degree angle, and the radius is not that sharp. It contain diameter 0.25. So the depth of the notch is 2 millimeters, as you can see in the picture. Okay, so when you put it at the anvil of the chopping machine, it need to be at the center of the anvil. We use the 4 millimeters using special tool that are giving. Okay, so that the notch is facing on the left side, it not at the bottom. So as you can see, the impact load, we strike it on the back, so the notch is facing on to the front. It has to be at the center at the anvil, so you can get the good result. Okay, that's all for me. Thank you.